Hello ladies and gentlemen, we're here with this particular problem. This is still recursive and linear functions. So now we already went through the Fibonacci sequence. If you didn't see that video yet, you have to go back and watch that before you watch this one. It's really important so that way you understand what a recursive algorithm is and everything else. So this is what we do with this from right here. We have this problem. Cohn decides to take a job with a company that sells magazine subscriptions. He is paid $20 to start selling and then earns $1.50 for each subscription he sells. Fill in the table, blah, 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 yakety smackety. So we're going to use a recursive algorithm to do this. So we start out with how much we're starting with, 20. So m sub 0, so instead of using what we had in that other one, a sub 0, we're now using m sub 0. So n sub 0 starts at 20. So this is here 1, 2, 3, and that last one's supposed to be 4. So this is what we do. Now, each time this person sells a magazine subscription, he gets an extra $1.50. So it's 20 plus $1.50. Now, where I get this 20 is from the previous cell. Because right here, this is our beginning amount. This is what we need at first to do anything. So this is 2150. Now we take this data and we put it down here because this increases by $1.50 each time. So 21.50 plus $1.50, that gives us $23. Then we put that down for the next one. 23 plus 0 plus another $1.50. Well, now that becomes $24.50. Of course, the last one, if we have $24.50 plus $1.50, and that's 26. Now, I know it's easier to go ahead and come up with a linear relationship. Each time we sell a magazine subscription, we multiply by 3. But that's not what's going on here. We're taking the previous information and we're just adding it on. So if we go by the old-fashioned rules, by the mx plus b, where m is y, or the range, that's equal to $1.50 times x plus 20, because that's our beginning amount. Now, this is all well and good, but we're not going to be using this particular form. We're using something called recursive algorithms. So recursive rule, first off, when we go ahead and come up with this is very important. We're going to be using m sub something. We're using n sub n. Now, before I move on with that part, you see the fact that we went ahead and took this information and went to this, and we have this m sub 0. This is m sub 0 plus 1.50. Then for this next one, we have m sub 1 plus 1.5. The 1.5 becomes our constant, m2 plus 1.50. And then m3 plus 1.50. Now, the way this one is made, the way they put this information right here, these two are related by just the fact that each time you go up to the next one, you're always looking at the previous. So we have 4 minus 1, so that gives us 3. So that's what we're going to be saying. What do we do to go ahead and get this number? We always subtract by 1. So this becomes m sub n minus 1, because we're always looking at the previous cell, plus 1.5. Now, for these to work, we have to, for these recursive rules to actually apply, we need to put some more information. Where m sub 0 is equal to 20, and we need to know where n starts. So where n is equal to, well, we started at 0 in this case, so we're going to do 0, 1. Oh, let me see. Where do we start with n? Oh, I'm sorry. We always look at where we start right here. We started right here for this n. So now n has to be equal to 1, 2, 3, 4. Even though we're given m sub 0, we're going to start with this right here, so that way we can move on to the next one. And that's the way this one's set up. Now, if we want to change this, the only way we can change this if we go ahead and change our m's. But for now, I think that this is really the important part that we need to go ahead and be able to do. So let's not worry about number 3. We're not going to even look at that inside of our class. So basics to our recursive rules are this. If we have y is equal to mx plus b, our basics on how to do this is really simple. We're going to go ahead and I'm just going to go ahead and put this together really fast. If I give you this rule and I tell you n starts at 1, this is how you write this. These are the important parts. So we have m, or we can use other letters. So I'm going to use other letters for our list. This is u sub n is equal to, let me see. Yeah, that's what it's supposed to be. B, or no, our constant is always constantly this m, so this is plus m, and we have whatever we have in the previous data. So it's u sub n minus 1. And this is what we're going to be doing, where u sub 0 is equal to whatever our b is, because that's our start, and n is equal to, well, since we started with n minus 1, we're going to go ahead and actually, when we have our list right here, we always start with u sub 0, u sub 1. This u sub 1 is where we're going to be really starting. So this is going to be 1, 2, 3, and all the way out to infinity until we stop. All right. And so that should be it for this and how to do these recursive things. You're going to have to be able to put these together by yourselves. So there we go. Thank you very much. Thanks you for watching, and hopefully we will see each other in class. All right.